Okay, mega is capital M. Kilo is lowercase k. And then this blank line represents the plain unit. So you might have megagrams, kilograms, and then just plain old grams. Okay, you don't need to include a blank. The quiz for this will simply be having you write out the prefixes, write out the symbols, and you're also going to write out the power of 10, which we will write in together. Okay? So, these two up here, these are the big ones. Okay, mega and kilo are big. So their power of 10, mega is 10 to the 6, and kilo is 10 to the 3. Okay? So in other words, 1,000,000 and 1,000.
Megagram out there?
You could have a megagram. I mean, if you were measuring the mass of the Earth, you might want to go in megagrams.
So what's that measure? Like a kilogram is like a block of...
A kilogram is a pineapple, essentially.
No, but like a block.
Oh, it's a block of titanium.
Yeah.
So it would be 1,000 blocks of those blocks. Okay? Yeah. So a megagram is 1,000 times more. You'll notice that they differ by 10 to the 3, right? Okay, so a mega is 1,000 times bigger than a kilo. So those two are big. So because they are big, they have positive exponents. The rest of them are small, and so they will have negative exponents. So we have mega, we have kilo, those are big, and then deci, centi, milli. And these ones are 10 to the -1, 10 to the -2, and 10 to the -3. Pretty easy, right? -1, -2, -3. Then micro, again, we're going to go by 1,000. What is 1,000 times smaller than 10 to the -3? 10 to the -6 is a micro. So you could have a microgram or a micrometer. And nano is 10 to the -9. Okay, and we're not going to spend a lot of time using these in this unit, but I want you to memorize them so they are in your head, and then we will use them a lot in the second unit, so we will do that spaced repetition with them, okay, so that they will stay in your head for a long time. Now, you know me, I'm always, before we do that, actually, I want to show you how to write micro, okay? It looks like this. If here's our line that we're writing on, we start here and we go up and then up, and then we have a little tail. So the starting tail is long. The ending tail is short. And this goes on the line. So if I had 100 microliters, I would write 100 microliters, not 100 microliters. Do you see the difference between those two? These are both on the line. This one is way the heck up here. So not like that. And why the heck are we using this funny little symbol? Because there are so many M's in chemistry and science. There are meters, there is mass, there are moles, there's a quantity called molar, there is molar mass. And so and we have mega and we have milli. And so we kind of round out of M's. So we use the Greek letter M, which is called mu, M-U, mu, like a little kitten. Okay, mu, that is our Greek letter mu. So you can just practice doing that a few times. Okay, I will get a little picky on it. If you do the letter U, I will say, no, it is not a U. Although you will find that if people are typing, sometimes they'll use the letter U because it's just easier than finding the symbol mu in their little insert symbol section. Okay, so those are our prefixes. You will be expected to memorize them. I think we could have a quiz on that on Tuesday.
Did memorize the powers as well?
The powers as well, but would I leave you high and dry, or would I give you a mnemonic device? Remember, mnem is the Greek for memory, or at least something along those lines. Okay, so it is a memory device, a mnemonic device. And you already know most of it because you know liters, meters, moles and Kelvin, kilograms and seconds, liters, meters, moles and Kelvin, kilograms and seconds. Now, guess what? Mega, kilo, deci, centi, milli, micro, nano. Mega, kilo, deci, centi, milli, micro, nano. Everyone, mega, kilo, deci, centi, milli, micro, nano. Mouth along even if you're not getting it. Mega, kilo, deci, centi, milli, micro, nano. Now, you're like, but hey, you have not done the powers of 10, Miss Spence. Oh no, so we're going to change the second line a little bit. And instead of just repeating mega, kilo, deci, centi, milli, micro, nano, we're going to add in 631, 236, 9 is for the nano. Oh. Okay, so mega, kilo, deci, centi, milli, micro, nano. And then we just hit the same pitch over and over again. 631, 236, 9 is for the nano. Okay, so let's try that part. 631, 236, 9 is for the nano. Okay, one more time on that part. 631, 236, 9 is for the nano. Those of you who are not singing along, if you get it wrong on your quiz, I will not cry for you. You might cry for yourself, but I will not, because I am providing you with ample opportunity to make this stick in your head forever and ever. All right, so let's do it from the beginning with both parts of the song, the two lines together. So do you guys like that key, or do you want something a little higher or a little lower? What do you think? It's fine? Okay. Anyone else got a preference? Okay. Mega, kilo, deci, centi, milli, micro, nano. 631, 236, 9 is for the nano. Mega, kilo, deci, centi, milli, micro, nano. 631, 236, 9 is for the nano. Mega, kilo, deci, centi, milli, micro, nano. 631, 236, 9 is for the nano. And then you say, okay, I've got my 631, 236, and then I put in my powers of 10. Those are all powers of 10. The first two are positive, and the rest are all negative. Okay? So we have learned those today. We will do them again tomorrow. All right. And hopefully then they will stick with you over the weekend, and we'll have a quiz on this on Tuesday. Quiz Tuesday. All right. Thank you very much. Okay. Next, we're going to take a look at 1.5c, exact and inexact numbers. So this is on page 100. This has to do with sig figs. Okay? There are two types of numbers. One type of number you measure. Okay? One type of number you measure, it is approximate. You have made an estimation on a digit, yes? Those are exact numbers. Or no, sorry, those are inexact numbers. Inexact numbers are measured. They have a specific number of sig figs. Okay? And so we've been dealing up till this time with all inexact numbers. Okay, all the numbers we've looked at have had sig figs. All right, and now we are going to be looking at exact numbers. Okay, exact numbers are not measured. So one thing you could do is you might count things. If you have 4 eggs, can you have 4.5 eggs? No. Okay, maybe if you break them open and swish them up and then, separate. No. Okay, you have counted them. If you have 8 molecules, like if I said you have 8 water molecules, 1, 2, 3, 4, 5, 6, 7, 8, that is a small enough number that you can count them, and that is going to be exact. Okay. 17 elephants, we're not going to have 0.36 of an elephant. Okay, exact. 35 atoms, these are all exact. So we don't consider that they really even matter when it comes to sig figs. If you must give it a number of sig figs, you can say they have infinite sig figs. Yes? You could, if you wanted to say, I have 4.0 eggs, I have 4.00 eggs, I have 4.000000000. So forever, eggs, right? Because it's exact. I could add zeros from now till the end of time and never be done. And that's how many sig figs I have, okay? Exact numbers have infinite sig figs. This is going to become important when we do math with sig figs in Unit 2. Those of you in physics have probably already done it, okay? So when we get into math with sig figs, you have to decide which number in my calculation has the smallest number of sig figs. And that's how many sig figs your answer will have. Is the exact number ever going to be your smallest number of sig figs? No, because infinite is infinite. It is huge, huger than huge. You can never have more sig figs than infinite, right? Like infinite is just the end of, right? It's like it just goes on forever. You cannot get more forever than forever. It's just forever, okay? So These are all exact numbers. So when you look at your sig figs, like let's say we had a calculation where we said, let's say I had 3 apples times 0.38 grams per apple. That sounds like a very small apple, okay? But let's just pretend that's what we have, okay? What this would mean is if each apple weighed 0.38 grams, and I did that multiplication, 3 times 0.38 equals 1.14, I would look at this and I would say this number has how many sig figs here? 2 sig figs. 3 apples, exact or inexact?
Exact.
Exact. Okay. And this per 1 apple, that is also an exact number. This 0.38 grams has to have been some sort of average, right?
Yeah.
Someone has gone and averaged all of the apples and they're like, yep, close as we can get is 0.38 grams. Okay? And that's why this one has some uncertainty in it. And this one doesn't, because it's like that many grams per exactly 1 apple. So we would have infinite sig figs here. I can show the infinity sign. You guys know the infinity sign? Okay. This little symbol here means infinity. It's like a sideways 8. So we have infinite sig figs in our 3 apples. The 1 apple is exact, so it has infinite sig figs. This guy here has 2 sig figs. So when I write my final answer, this is a new thing that you're not going to be responsible for this unit. It will be next unit. We would have to take our final answer and round it to 2 sig figs. Our answer cannot have more sig figs than the smallest number in the question. Okay? So if I have 2 sig figs, my answer is limited to 2 sig figs, so I would round that to 1.1 grams. Okay? You don't need to know how to do that. What you need to know is that exact numbers will never limit the number of sig figs in your answer because they are always more sig figs than everything else. So you need to be able to recognize infinite things so you can ignore them when it comes to sig figs. So things that have been counted are exact. And they have infinite sig figs. However, if the number gets big enough, you can probably assume we have made an estimation at some point. If I say we have 4.3 times 10 to the 6 atoms, and if you remember, we would take our 4.3 and we would move our decimal place 1, 2, 3, 4, 5, 6 places. All right, which would give us 4,300,000 atoms. Do you think that's an exact number, or do you think maybe we have a few more atoms more or less here or there? More or less here or there. When you get into large numbers, you can no longer say, yeah, I know, I've counted them. Okay? I would say anything up to about 100. You can probably just count. Like if I gave you 100 molecules, you could assume that we're probably dealing with like little molecular models, right? Something like this. And we'd be like, I'm going to count 100 of these. But anything over 100, probably it'll be an estimation. I'll make it obvious. I'll never make it something where you're like, is it exact? Is it not exact? I just don't know. All right? Ask yourself, does it seem reasonable that we actually counted out exactly that many atoms? And the answer is no. And that means it is not exact because we haven't actually counted. We must have done some approximating. So counting is one way a number can be exact. defining, these are also going to be exact and have infinite sig figs. So along the way somewhere, you know how the Americans still use inches and feet and pounds and all those things? Okay. Hi. Yeah, sure. Okay. Well, if that's the case, they actually decided to define 1 inch as being exactly 2.54 centimeters. That is the definition of an inch. Okay, exactly. Not like 2.54 plus or minus, not point anything else, just exactly that much. And of course, the centimeter is based on the meter, which is based on a wavelength of a particular light. Okay, so, or is it the distance traveled by light in a vacuum or something like that? Anyway, whatever it is, there is a standard for the meter based on something physical. All right, and then we've defined the inch as being exactly 2.54 centimeters. If you are going to be asked to use these numbers, I would tell you that exactly, I would write that exactly in there. I don't expect you to remember that. Does that make sense? Okay. These other ones, I expect you to know that they are exact. Are there approximately 60 seconds in a minute?
No.
Or are there exactly 60 seconds in a minute? Exactly. So those ones you know are exact. Are there 24 hours in a day approximately? No, there's exactly 24 hours in a day. Now, when it comes to a year, we end up with some weirdness happening, right? Where we have to have a leap year, and then we have to have leap seconds every once in a while, but a day is 24 hours, okay? Any of the metric conversions where you're going from metric centimeters to metric meters, those are always exact. Metric to metric is always exact. Now, I'm shocked at how many people don't know this, but it's happening more and more because you guys don't have, how many people regularly pay for anything in cash? So you'll probably know this, but there might be 1 or 2 of you out there who don't. $1 is 100 cents. Yes, I know, but I realized about 5 years ago that I put like a question that had, you know, like how many cents in a dollar, like you needed to use $1 equals 100 cents as a conversion factor, and people didn't know. They were like, how many cents are in a dollar? And I'm like, come on, cent. Anyway, this is exact. There's not approximately 100 cents in a dollar. You should know that. Now, quarts and gallons, these are both the, this is the American measurement. Also known as imperial. And if you are going from imperial to imperial for quarts, if you're going from quarts to gallons, those are also always exact. There are exactly 4 quarts in 1 gallon.
What about like, except for what about imperial to metric?
Imperial to metric, other than the centimeters,
Yeah.
imperial to metric. One of the units, the one with the decimals in it, is going to be inexact.
Always.
Okay, yeah.
Except for the inch.
Except for the inches and centimeters, and that one will say exactly.
Okay.
Okay, it'll literally have that word there for you. Okay, so once again, here we have metric and metric. So that's exact. And we have imperial and imperial. And so that is, again, exact. So if you're converting within one measurement system, those numbers will be exact. But yeah, just as Elsine was saying, if you're converting between metric and imperial, those will be inexact, except for the one that says exactly. Yes, the one that says exactly is exact. Yes.
So we have worked the kilogram and measure like a block of magnesium.
Yeah.
Is the American imperial system based on something?
I don't know. I know that feet were supposedly after some Roman emperor's foot, like their literal foot. And I assume that, you know, back in the day, there were many different feet. You know what I mean? Like there was a foot that was this long and there was a foot that was this long, and it depended on where you were and who had the stick, you know what I mean, that measured it. So yeah, eventually along the way, things did get standardized, but I don't know what the imperial standards are. Yeah, if you're interested, you can like go look up imperial measures, what are their standards, and I'm sure Wikipedia will have a nice rabbit hole for you to dive down. Okay? All right, but if we're going from metric to imperial, that's going to be inexact. At least the decimal number. So for example, here we have metric, metric, metric. And on the other side of those equal signs, we have imperial, 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 imperial. So the decimal number is inexact. But the ones are exact. So basically, you are responsible for knowing the metric units because you've already learned the metric units. They're the SI units. You are not responsible for knowing the imperial units. You will be given those numbers anytime you need them. Okay? All right. Most often when you have an equivalency where you have two things equal to each other and you have a 1, the 1 is always exact. So once again, here's all the things that are exact. We'll put exact in blue, exact, exact, exact. But then all the rest of them have decimals, and so they have sig figs. So for example, we have 101.325 kilopascals. Delcine, I want to know how many sig figs in that number. 101.325.
There is 3 sig figs.
Uh-oh. 101.325. I asked you on purpose.
Well, there's the number in the middle, is 1 and 1, so 1, 2, 3, and then the decimal points, so 1, 2, 3, 4, 6.
Yes. Didn't you say 3?
I said 6.
Oh my God, I'm just hearing things wrong. Never mind. I'm losing my mind. Just ignore me. Okay. All right. How about, remember we had that number, the mole, 1 mole is 6.02 times 10 to the 23. Do you think that there are exactly 6.02 times 10 to the 23 particles in 1 mole? No, there's actually a lot more decimal places. There is an exact number, but the exact number in a mole is, let's look this up. Exact number of particles in a mole. It is 6.0221476 times 10 to the 23. And I'm sure that is defined by some standard somewhere. I think that's the number of particles in 12 grams of carbon-12 atoms.
Oh, wow.
Yeah, so there we are. That is a mole, but we don't want to write that number of digits all the time, so we just use 6.02. All right, so it would have 3 sig figs because we're rounding off. Okay, so with that being said, you can try some of these. Per means exactly 1. 45 miles per hour. Again, we have that 1. Percent means per 100. It means exactly 100. So if you have 25.9%, that means 25.9 out of exactly 100. So you would have 3 sig figs here, and you would have infinite sig figs in the 100. Constants are not exact. They are usually calculated from measured values and are given to finite sig figs. So 6.02 times 10 to the 23 has 3 sig figs. It is not exact. One mole of gas takes up 22.4 liters of space. That is a measured number, so that would have 3 sig figs. The actual number is 22.413962. But that's exhausting. So you guys can try these exercises here, and then you can finish the quad beam balance activity, pages 18, 19. You can prepare for tomorrow's quiz, which is 1.4 D, E, and F. You can prepare for Monday's quiz by finishing off pages 113 and 116. And if you're finished and you're bored, you can work through 1.1A. There's going to be some enriched bonus section on the test on equipment. If you don't get to that, it's no problem. Remember, enriched stuff doesn't count against you. So if you just don't get to it, that's fine. Okay, so we have a little bit of a work period today. All right. And I'll get your quizzes back to you from last day.
You can't do this for anything right now.
You can do that thing right now. Yeah, sure.
Because then I'll leave that prepared for tomorrow.
Yeah. So I'm just going to hand back the quizzes and then we can do that, okay?
Sure. I'll just finish off the top of the third.
Yeah.
Well, work. Just if it's one day.
I know. Hi. Yes. Yes. Why don't I get back to you first? You can check. Okay. Okay. Where did I put quizzes? They're in my bag. Nope, they're not. They must be over there.
Oh, I am.
He must need it.
Oh, okay. I'll give you that. How do you calibrate this again?
So what you're going to do is you want to make sure that this is at 0, and so you will twist it towards you, okay? Are you sure?
You kidding? So once you get that fry your fine. I'm scared to take one out of go too far, you have to be salvaged all over. Thank you. Not too far. Okay, so once you finish that, number 3 is page 18. Yes, yes. That part. It's all good, don't worry. Yeah. Okay, folks, remember for the quad beam balances, they are up here on this part. Okay, so that's this one here, the quad beam balance. I didn't do my D very well. Be a D.
It's just a past. It doesn't like it. Sometimes it can show the higher space of
Away. This is the wrong block. That's why I'm not seeing the one on here. Okay. All right. Adrian's away. Ayusha's here. Jay is here. Zenny is here. Shiko is here. Hi, Zenny. Yeah. We did an activity called Using the Burette. Okay. And if you want to come in during flex, you could come in and we can complete that in fairly short order. Yeah? Okay, cool. And we did a quiz yesterday.
Okay, yeah.
On counting sig figs.
Yeah, I can come back tomorrow.
Perfect. That'll be great. Okay. And I think that's it. Yeah.
What about my unit quiz?
I've got that. Let's see. That's yeah. There we go. There you go. Yeah.
Oh wait, can you check for 0 to tell me that?
I will do that, yes. I'm just gonna get this gentleman. Yes.
It's explanation. And the question goes that we explain.
Right.
So why give us a law? That doesn't make sense. That doesn't make sense.
The SI yeah. Don't always come back with yeah, and if anyone wants to redo any quizzes today, you can do that as well. Okay.
Didn't he write it on the blackboard?
Yeah, it's not
Okay, now. Come around this side. Okay. Actually, here. This is. So that's.
Somebody said. Even certain system questions could ask those.
Oh, yeah, we forgot what value.
I just thought of
Yeah, yeah. Yes. Now, what's your?
Would you rather like to make mistakes?
Yeah, that's one. You get someone sick.
Oh, did you? That's better. And that's the reason I had no seats around it, because that way I can talk to you before you guys. Right?
Just.
Miss Spence, can I go with you? Thank you.
I know it's not good, but it's not like you watch this.
Get the sign. Miss Spence.
Yeah.
That's it.
That was beautiful.
You saw your hair.
That's what's. You say graduation is.
I mean, it's like, okay. Actually, you know what? The smaller.
Thank you very much. Hi.
Do we have to fill it up with water?
Does it say to fill it up with water?
No.
Nope, then don't.
It's always the same one. Several. Maybe you can just follow that or something.
And what? Do you feel like one? That was pretty exact, right? No, I said
I just trying to follow the
higher, not exact experiments. See? See?
kind of hard at some.
If you lower your back.
Our is the whole of your.
If you cross further, you go.
I just feel like.
You go heavy, heavy,
Yeah, now you cancel that.
Go to the right
all the way to the top.
to the
Like every neighbor, I'm just like, no, I can.
Yeah, so it's just like that. Yeah.
God.
Exactly.
Because then we can change these.
Yes, that's what I said. Just go back.
Yeah, let's do it. Yeah.
What am I saying here?
Like you kind of like,
I think I
you have to read like you read the summary.
Oh, okay.
This one has two. Yeah.
What I
Okay, I'm done.
kind of ABC is like required to walk over 95, so. It doesn't really matter, but you, if you can't get this high marks, you basically that you can get like this high, this high score. So.
Okay, yeah, you're right. Sorry. It's 0.5. And then just from treating like examples.
Yes. Okay.
All right, very close. Have something? Oh, bring it.
We like, I was ready to do this.
I know.
Like 80% arm, and then now 20%.
Okay, my deal is that if I don't do well this week, I'll just walk it.
Yeah, so
I live on
use
like
that.
my
Should I do? No,
parents.
just before like we keep going. Like,
I asked my friends a lot.
I was just thinking about
Yeah, he said he found
just like, but it's like, it's better for me, yeah, it's better for working. It's kind of like, it's better for me, because just like, because like, you're each one, like, everyone is to talk positive, like, obviously, yeah, things on the everyone, what they repeat first year. Yeah, actually explain like for repeating to whole class, but it means just like you.
Yeah,
Like, we all thought that when we do this, then we just maybe I really was too positive questions. It's kind of like to be what
It's there.
is here.
okay.
I just started.
Yeah.
Just like
You still need it for now.
did it.
For now, we still need it. We should put it away.
I just like this.
Don't put this away like we're finally done with it.
I'm the one. I don't know. It's. I didn't know that.
Don't get what?
I think
Where's that measurement wrong?
just thinking very hard. Just like someone just said that you do things that you've done.
Yay. We're kind of steal things.
Really Everyone's trying. Everyone wants
She'll get a notification. You'll time my pick. Bro, I didn't know. I used to like the power of
Crazy.
because then it just seems like
Yes.
I'm just trying to
You're kidding. I'm not
just understand.
still have
Analytical balance. On the box.
Is it like you think like is it like to take like less a very big deal that it's like you say that everyone can take.
Wow, because
It's not very big deal, but the real problem is like he just gets so much confidence and he cannot understand it. He doesn't know how to do it. Because that's a big deal. This is problem. It's so amazing. So 1 year ago, I'd say science again.
just to run my life.
Just that it might be almost then again, and you live in science again.
Where are they?
A lot of guys will be used.
Yeah, it's my diagram.
Bro, I saw
Dave was
I played again.
You mentioned Aiden, and I was thinking Justin, and I wanted to talk about
Yes.
Being expensive, that's trying to
For every house, they always let you do like the
careful.
actually at physics, but
Yeah, you could actually.
Okay.
kind of good right now.
Hello.
It's kind of like easy right now.
Yes.
It's hard to say, but
Nice. And
hard to say. By the way, it's kind of
that's nice. Yeah.
because it's also I still I need to spend some time on this, but I can do this.
Oh,
It's not like I'm doing it.
Oh.
It's not very. Maybe it's they will have one or two, but it's not very but it's basically I can't understand every word that I use. I use every example. I use translator. I use GPT. Even GPT is give me the so that make me confused. The GPT, you know, so I'm kind of like I want to get
You ever seen me?
this year. I want to get all good Microsoft FC and bring out.
Yeah, so everything like yeah, no, it's scale. It's just one. That's what she's trying to do. See, it's just unclear. If you answer the quadruple balance, then it goes up to 460.
Everyone knows that. Just like and you get out of
Okay, nice. You got the right number of sig figs. That's great. Pardon me?
Not really. You're
Specifically.
Yes, they do. That's your uncertainty. Yeah, yeah.
You don't like her? She hasn't won in so many years. I don't know, I think we have to work for stop doing time. My other
distance.
I know the
Just
Ladies and gentlemen, I would say your homework, unless you want to work ahead, should be to prepare for tomorrow's quiz. So that would be 1.4 D, E, and F. Okay?
What?
I know.
Okay.
The velocity is actually
But A is actually, oh my god, lying to the sorry, G is B. Never right. I think you have that like.
Oh.
Well, but I am right. A book, FTC, Jay, David, and the back of Adrian for last week. I think I would kill myself just to hurt. Wait, I'm sure it's way on the there is.
Oh.
No, that's all. And you don't not. Right now. So. Yes. Yeah, and I don't know what happened here.
Just do the problems. Yeah, just the questions if you, yeah, and then if you have any questions, you can. I mean, no, I'm not gonna do that. It will just be questions. It'll just be problems.
So I should flex.
Yeah, okay? Yes, you can read too many quizzes. And you come in back to some point.
Wait.
But I can't find it.
Sasha, you're it's time or?
Either flex time or lunchtime, I'm good.
Oh.
I don't know what happened to it. I know you
Yeah.
had two of them and it just, I was
Yeah,
like,
it's-
in my pile of things, I didn't have any. Anyway, there you go.
Thank you.
Yeah.
Should I be hearing Thursday or like Friday flex time or like
Either one. I don't care. Up to you.
All right.
So if you want to study for this quiz and not worry about the other one tomorrow, you could do the quiz, the re-quiz on Friday.
All right.
Yeah?
Thank you.
See you. Yes.
Final 5 minutes in each.
Okay, just sit down for a minute.
Is it quiz not take off?
No, we moved it to tomorrow. Yeah.
Hello.
Hi.
What is this?
This is because it's reading down. That's a burette,
Oh,
like the ones we used yesterday. If it reads down, it's a burette. If it reads up, it's probably a graduated cylinder. Hi.
for the quiz, I
Yes.
think
Because I had
That's okay.
Can I do that?
You can do it after school. We might even have some time today during class because we're having a bit of a work period.
Okay.
So we'll learn a couple things and then have some time.
Okay.
yeah.
Yeah.
Perfect. Good.
What was it about? I forgot.
Counting sig figs.
Oh, okay.
Yeah, you good with that?
Yeah.
Okay, perfect. Perfect.
Yesterday, yes. Okay. What am I doing? Right. Yes. Yeah.
The average is gonna fail.
They're coffee shit. They're not. It's not that it's I was there in I'm going to hand back your. Actually, I'm not going to. Never mind, pretend I said nothing. Today, we're going to be doing metric prefixes. 1.5c will be looking at exact and inexact numbers. These will be short. And then we're going to finish up the quad beam balance activity. Prepare for tomorrow's quiz. 1.4 D, E, and F. And you'll notice over here, homework 1.4 D, E, and F. If you choose to do more of the other stuff, because if you've already done this and it's really easy, then you can prepare for Monday's quiz, which is going to be on scientific notation. And then if you finish all of that, you can do some enriched bonus stuff. Okay? Nobody in my other class got to this, but that's okay. I always like to have more than you need, and then we can always scale back. Okay? Thank you. All right. So let us go to page 0.4a. Okay. Oh,